everyone. Today we're talking about the mole, the chemistry mole, which is a number here, 6.022 times 10 to the 23rd. It is a counting number. So examples of counting numbers are things like 1 dozen. 1 dozen, everyone knows, is 12. Sorry. We also know counting numbers like a ream. If I say you have a ream of paper, that means you have 500 sheets of paper. If I say you have 1 minute, it means you have 60 seconds. That kind of thing. So kind of like a conversion factor. We do use the mole as a conversion factor a lot. But if I say I have 1 mole of something, it means I have 6.022 times 10 to the 23rd of whatever that thing is. I could have a mole of pennies. It means I have 6.022 times 10 to the 23rd pennies. But what we use it for is molecules. So if I have 1 mole, I have 6.022 times 10 to the 23rd molecules or atoms or particles, something like that. We do that because molecules are really, really small, right? We can't see them. You can count like 1 penny, 2 pennies, but you can't really count 1 molecule, 2 molecules. They're so small. So in this picture, that's right here, those are all examples of 1 mole. That is a piece of filter paper that it's like sitting on, which means it's about the size of your palm. So there is, let's see, like this one, that's 1 mole of zinc. That would probably be about the size of a quarter, maybe 2 quarters that are sitting in the middle of your palm. Not that much. Whereas like if you have a mole of pennies, you can get from the earth to the sun like 7.5 times. Earth to the moon. Dang, I forget. I looked it up once. I think it's Earth to the moon like 7.5 times if you like stacked them. So that's crazy. That's a lot, right? But we need numbers like this, the 1 mole. We need numbers that are that big times 10 to the 23rd in order to count really, really, really small things. So Amadeo Avogadro is the scientist that came up with the mole, therefore, which is the counting unit, the 6.022 times 10 to the 23rd. So therefore it was named after him. So that is called Avogadro's number or Avogadro's constant. But 6.022 times 10 to the 23rd is the number. You're going to use that number so much that you should memorize it. So when we use it in math, we use it to convert from molecules. Like if I want to know the mass of a certain number of molecules, I can do that going through the mole. The mole is the only thing that can be compared. And I could even go from mole of A later to like mole of B. So that means I could find like the mass of A and I could convert that into the mass of B. That's sort of where we're headed. We're doing simpler today. We're just going to operate within 1 compound. Instead of changing compounds like A to B, we're going to operate within 1. And we're going to use dimensional analysis to do that. So in order to convert from grams to moles, this conversion here, the mass to moles, we need to use grams per mole. This is the molar mass, which is found on the periodic table. We learned how to find that last time when we learned how to find average atomic mass. Another name for average atomic mass is molar mass. So we find that on the periodic table. And then to convert from moles to atoms, molecules, formula units, particles, in order to make that conversion, we use Avogadro's number. So let's put it into practice. Okay, so how many moles of magnesium are represented by 0.200 grams? So just like the conversions we've done so far, you always want to write your given first. So 0.200 grams. And just like the conversions so far, we want to put the grams on the bottom because we want grams to cancel out. So grams divided by grams. Remember, this line means divide, this line means multiply. I can't convert, or I'm sorry, I can. It's asking me to find moles. So I'm starting with mass here and I'm looking for moles. So moles is going to go on the top. And then what number do I use to do that? I use the molar mass, which means I need to look up the molar mass of magnesium. So I did that actually here. So the molar mass of magnesium is right here. So it's 24.31. So 24.31 0.31 grams for every 1 mole. In a mole to mass ratio, the mole always gets the 1, and then the mass from the periodic table always goes with the grams. So in order to solve, I'm going to take 0.200 and divide it by 24.31. And I get, 0.00823 moles of magnesium. So I had 3 sig figs in my given here. Therefore, I needed 3 sig figs in my answer as well. So there's my complete answer. Now, there's a second part of the question asking how many atoms in this piece of magnesium. So I can either use my answer to continue on, or I can start back at the 200 grams. I'm going to start back, the 0.200. I'm going to start back at the 0.200 grams of magnesium, just because I don't want to use like a rounded number as a given. If you took the whole value, which I think was like 8227 something, if you took the whole value and continued on with that, you could do that, but you don't want to take a rounded number as a given. So I'm going to start back with the given, which means this is all going to be the same, because notice I can't convert straight from particles to mass. There's nothing there, right? Like I was not given that conversion. You can't do that. You have to go through the mole. So it's like a train station where like I'm starting here and I'm going to the mole, and now I'm going to go up to my particles. So now that I'm at moles, right, I've gone from mass to moles. Now I can do my conversion from moles down here, and I'm changing it into atoms. So moles into atoms. So again, in these mole conversions, the mole always gets the 1, and then the atom gets our Avogadro's number, 6.022 times 10 to the 23rd. So now, in my calculator, I'm going to do 0.200 times 6.022 times 10 to the 23rd divided by 24.31. And I get, again, I need 3 sig figs, so again, I get 4.95 times 10 to the 21st power atoms of magnesium. So there's my answer. So you saw a one step where I'm doing straight from grams to moles, and then you saw me go straight from grams all the way to atoms. You have to do this mole conversion in the middle. And I can show you that my grams cancel with my grams, my moles cancel with my moles, and I'm left with atoms, which is my final unit, which is what it asked for. Okay, one more example. So past the periodic table, here we go. So problem, what is the mass of 4.2 times 10 to the 23 atoms of sodium? So again, I can't go straight from mass to atoms. I know I'm going to need to stop at the moles in between. So I'm going to start with my given, 4.2 times 10 to the 23rd, and this is atoms of sodium. The symbol for sodium is Na. So atoms of sodium. So I'm going to just head back to this slide again. So I'm starting with atoms. So I'm right here starting with atoms, and I need to get over here to mass. So can I go straight from atoms to mass? No, I have to go to moles. Then I can go from moles over to mass. I have to follow that path. So I'm going to convert first atoms to moles. So atoms goes on the bottom, moles goes on the top. Atoms goes on the bottom because I need to cancel, and then I can insert the numbers. If you remember, the number is Avogadro's number. And remember, the mole always gets a 1 in those mole to atom and mole to gram conversions. So 6.022 times 10 to the 23rd atoms. Again, I'm still in sodium. I did not change my element. So now that I'm at moles of sodium, I can now convert to grams using the molar mass from the periodic table. So I'm going to set this up by putting moles on the bottom because that's what I need to cancel, grams on the top because that's what I need to change it into. The mole always gets the 1. Then I'm going to go over to the periodic table and I'm going to look up the mass of sodium. So here's Na, sodium, it's 22.99. So I'm going to put that here, 22.99. So then I am going to take 4.2 times 10 to the 23rd, multiply it by 22.99, and then divide it by 6.022 times 10 to the 23rd, and I get 16.034. How many sig figs do I need? I need 2 sig figs. The times 10 part to the 23rd, that does not count as sig figs, so I have 2. I have 4 and 2, so 1, 2. So my answer needs to have 2, so 16.03 rounds to 16 grams of sodium. So again, my atoms canceled with my atoms, moles with moles, and I was left with grams of sodium, so those are my units that I write. And that's it. So you guys have a couple of, well, you have a bunch of example problems to do, so head on over to that assignment and let me know if you have questions.